Hi folks, welcome back to our discussion on KB values. We've gone through the KA examples. We're now going to deal with the KB. Okay, and remember from our notes, remember this is going to be slightly different from those KA calculations because we're dealing with the KB instead of the KA, and we're going to deal with the OH minus concentration instead of the H3O plus concentration. But we know from previous lessons that we can interchange between these values depending on what we have and what we're given. So let's work through these KB values to understand what's going on. Okay, so this first question, we are looking with this concentration of a methylamine being 0.5 molar and having a KB value of 4.4 times 10 to the negative 4. We want to find the overall pH. Okay, so once again, we're going to start off with our equilibrium equation and our ice chart. All right, so we've got this, so we've got our methylamine plus water produces the methylamide ion and the hydroxide ion. Okay, looking at our ice chart, once again, we ignore the water. It is the only pure liquid anywhere in this equation, so we do not consider it. We are starting off with a 0.50 molar methylamine, and since we're starting off with that, we would have 0 of both those. Okay. Now this is very similar to that first Ka calculation we had, where we are going to add a certain amount of both of those as this breaks down into that side here. So we're going to add x on those, and we're going to subtract x on this side. Okay, we got that lovely 1-to-1 ratio. Do be careful of those ratios. You may see a 2-to-1. Make sure you take that into consideration for this equation and when you're dealing with your KB expression. Okay, so we're going to look here. We've got a 0.50 minus x, an x, and an x, right? That's our equilibrium situation. Those are our concentrations. Now, we want to pay attention here for the 5% rule. I've got 0.5 minus x. And so we said if the concentration was 1,000 times greater than our KB value or our Ka value, we would ignore that. 0.5, 4.4 times 10 to the 4. So we can make that assumption, assume that this is approximately 0.50. Okay, so let's rewrite this really quickly here. We are looking at equilibrium situation where we have a 0.50, an x, and an x. And now we can look at our KB expression. Concentration of our reactant, or products, divided by the concentration of our reactants. Once again, ignoring water because it is the only pure liquid. Okay, well, we have these two concentrations and we have this concentration. So this would be then x squared over 0.50 equals our KB value of 4.4 times 10 to the negative 4. Okay, 4.4 times 10 to the negative 4. Now, we're solving for x in this situation, and so I get x, which is equal to my OH minus concentration, is equal to 0.0148 molar. Okay, so that is our OH minus concentration. And our question here was to find the pH. Well, we're going to have to first find our pOH, which is equal to the negative log of our OH minus concentration, which we have down here. This gives me a value of 1.829. My pH is just 14.00 minus my pOH. which gives me a value of 12.171. Looking back to our original values, I have 2 sig figs, 2 sig figs. Everywhere we have 2 sig figs to start. That means I need 2 decimal places in my logarithmic calculation. So 0.5 molar methylamine will give us a pH value of 12.17. Okay, so very similar to those Ka calculations that we saw in the last one. Let's move on to the next example.